forceps CHF. This is the fourth part of the series on viscosity. Here we will study about terminal velocity. Terminal velocity. When an object is falling through a liquid, it is subjected to different types of forces. One is the viscous drag, which we denote as F suffix V, which we can see in the diagram. Second is the buoyant force, F suffix B. And third is the gravitational force, which is denoted as W. Now, due to gravity, the velocity of the body increases. It is increasing until it reaches the terminal velocity V. The viscous drag is acting upwards, that opposes the motion of the body. From the Stokes law, the viscous force F suffix V, it is going on increasing. The buoyant force Fb, that is the upward force exerted by the liquid, it opposes the weight of the body. Now, a stage will reach when W, the force W, it will be equal to the sum of the buoyant force and the viscous force. So, Fb plus Fv. At that time, no net force will act on the body. The object will move with a constant velocity called as the terminal velocity. So, we can define terminal velocity. It is the maximum velocity attained by a body that is falling through a fluid or a gas. So, let rho 0 be the density of the material of the spherical body. It is having radius r. Let rho be the density of the fluid. Therefore, the true weight of the body, which we have denoted as W, it will be equal to the volume of the body into the density of the body into g, that is the acceleration due to gravity. Volume of the body is 4 pi 3 pi r cube, density of the body is rho 0 into g. This is W. Fb is the weight of the liquid displaced. We can write down that as the volume of the liquid displaced into the density of the liquid into g, which is the acceleration due to gravity. Volume of the liquid displaced will be the same as 4 by 3 pi r cube into density of the liquid is rho into this is g. Now, if V represents the terminal velocity of the body, then using the Stokes law, the upward viscous drag force, we can write it down it as Fv. It will be equal to 6 pi V r eta, which we had seen in the earlier video. When the body acquires terminal velocity, we get W is equal to, W is a true weight, it will be equal to Fb plus Fv. Fb is a buoyant force and Fv is the viscous force. We will substitute the values that we have seen in the earlier slide. W is 4 by 3 pi r cube rho 0 into g. Fb is 4 by 3 pi r cube rho into g and Fv is 6 pi V r eta. We will take this term 6 pi V r eta on the other side, and here on the other side we get 4 by 3 pi r cube rho g minus 4 by 3 pi r cube rho g. If you observe here, we can take 4 by 3 pi r cube into g common. So, that is done here, and so in the bracket we get this rho 0 minus rho. Now, we are finding the terminal velocity, the formula for the terminal velocity. So, we will keep v on this side and take this 6 pi r eta on the other side in the denominator. So, after certain calculations of certain terms, we get finally v is equal to 2 r square into rho 0 minus rho into g upon 9 eta. So, this is the expression for the terminal velocity acquired by the object of radius r if it is dropped through a liquid of viscosity eta and density rho. The terminal velocity is directly proportional to the square of the radius of the body, we can see r square. It is inversely proportional to the coefficient of viscosity of the medium, we can see that it is inversely proportional to eta, and it depends upon the densities of the body as well as the fluid, you can see rho 0 and rho. Thank you for watching this video.